All right. I'll take any question you have at homework. Go ahead.
This is number 7 on 8.2.
Go ahead.
And it is do the partial integral of x times the square root of x minus 44. I got a little bit...
X minus 44?
Yeah. I got a little bit mixed up where there was something with like 5/2 power that it sort of looked like it just like...
Well, we've done these before. And the way I recommend you do these is to let u equal the square root and then solve for x and dx. So we have done these before. Do they say that you have to use integration by parts to do this?
Yeah, because I did the practice another one, and then like I didn't get the right answer, and then I went through this show solution, like how they
Yeah.
would do it, and even following what they did, there was something with like the 5/2 power that I didn't quite wrap my head around.
Okay, because my preference is to let u equal the square root of x and just do it that way. That's what we did before. As an integration by parts problem, let's give it a shot. Let's let u equal x, the dv equals the square root of x minus 44 dx. du is dx. v is the integral of this, and we can integrate that. This is x minus 44 to the 1/2. So it's going to be x minus 44 to the 3/2 times 2/3. Okay, that's the integral. So what do we have? This integral is equal to u v. So it's 2x, x minus 44 to the 3/2 over 3, minus the integral of v du, 2/3, x minus 44 to the 3/2 dx. That's an integration by parts. Like I said, I still think by letting u equal the square root like we did it before, it's probably simpler to do. But this does work. This does work. So what do we have here? Well, all we have to do is this integral. And this integral is u to the n form. U is x minus 44. The du is dx. So we get this. 2x, x minus 44 to the 3/2 over 3, minus the 2/3. This is u to the 3/2. It would be x minus 44 to the 5/2 times 2/5 plus c. And that would be it. Now, I don't know if they want you to try to...
They need you to put it in one fraction. If I'm not mistaken, they had a 7 as the denominator. Come up through the loop.
Well, I can see how we could take a 2/3 out, and we could take an x minus 44 to the 3/2 out. If you take a 2/3 out and an x minus 44 to the 3/2 out, okay, I'm left with an x minus 2/5. Now, I've taken an x minus 44 to the 3/2 out. That leaves an x minus 44 to the 2/2, which is x minus 44. So, 2/3 x minus 44 to the 3/2 times x minus 2/5 x plus 88/5. Good grief. I don't know what the heck else you want to do here. This is, we can combine these two. Obviously, this is 5/2 minus 5/5 minus 2/5. This is 3/5. So we get 2/3 x minus 44 to the 3/2 multiplied by 5 over 5. We'll get 3x over 5 plus 88/5. I would take a 5 out. I would get 2/15 x minus 44 to the 3/5, and then a 3x plus 88, and I don't know where else you're going to go with that thing. Check that out. How's that look? It's a mess. And I wouldn't generally recommend an integration by parts on a problem like this, Should be done as a substitution where u is the square root, but parts does work. Okay. The rest of this is all algebra, you know. I don't know if you can find on WebAssign exactly what it has for an answer. It should be this. If it's not this, then WebAssign is wrong, you know. What can I say? All right. Any other questions? Yes? Go ahead.
After that, okay?
Okay.
I'm just going to keep it here.
All right, we'll keep it right there. Oh, great. You can't even, oh, man, it's so complicated you can't read it. Oh, man. Holy, this one's a whole paragraph. All right, figure the vertical side for a poured. Okay. All right, so poured concrete that weighs, okay, this is a, back in the last chapter. So we have this. And we have y equals a negative 2/3 square root of 9 minus x squared. Okay. And what we want to do is concrete is 100, the density here is 140.7 pounds, okay, per cubic foot. Okay. Determine the force in this part. Okay, round it, okay, and this is 2 feet. This is 0 to negative 2. All right, let's take a look. Here we go. What we'll do is do this piece of it on this half. This is a fluid force problem from the last chapter. Call this delta y. Okay. I'm going to double it. Okay. I'm going to find the force on this half of this ellipse and then double it. The force is going to equal the integral as y goes from negative 2 up to 0. The density is 140.7. The depth is a negative y. Okay? The length of this is x. And there's the rub, as they say. That distance from the y-axis is x. But we're integrating in terms of y. What I'm going to have to do is take this, which is y in terms of x, and get x in terms of y. So what I'm going to have to do, all right, right now it's this. It's x dy. And it's multiplied by 2. So right now the force is 2 times this. It's 281.4, negative 2 to 0. Take the negative out. You have a y. Now we have to get x in terms of y. So multiply by a negative 3 halves. Okay. Square both sides. Okay. I would bring the x squared over here and the 9/4 y squared over there. And then take the square root. Okay. And that's what x is. So we need that in here. Okay. Alrighty. Now let's do it. How do you do that integral? What form is it? I can't quite hear you. U to the n is exactly what it is. Okay. The u is equal to 9 minus 9/4 y squared. The du part would be a negative 9 halves y dy. That's okay. I'm going to multiply by a negative 1 here and here. I have to multiply by a 9 halves and a 2/9. So I'm going to have a 2/9. I'm going to have a 281.4 I have negative 2 to 0. I have this to the 1/2. So I'm going to write it this way. Okay, to the 1/2. And then I have my negative 9/2 y dy. Okay, is that about right?
They want an actual value.
Yeah. I'm going to keep on going. Okay? All right, so what do we end up with? Well, you're going to have to do the decimal part here for me. This over 9. We got negative 2 to, here, I'm going to do the integral now. I can do it. This is u to the 1/2 du. So it's 9 minus 9/4 y squared to the 3/2 times 2/3 from negative 2 to 0. Okay. And this is something I would do in Mathematica, but I guess we can do a little bit here. What do we got? We've got 4 times 281.4 over 9 times 3, 27. That's this. I'm going to substitute in 0. I'll get 0 here. I'll get a 9 to the 3/2. Okay. 9 to the 3/2 is 27. Wow, that's good news. Minus negative 2 squared is 4. 4's cancel. And then 9 minus 9 is 0. Oh, man, that is awesome. Okay. And now the 27's cancel. The problem turns out to be not too bad. It seems to me the answer should be 4 times 281.4. 16, 5, 32, 3, 111. I would say that we have 1125.6 pounds of force. Yes. What a pain that is. But that's what you would do. How are you doing, Carolina? Not too bad. Not too bad. Not too bad. Lost in chest before the class. Couldn't do a foot-pound problem there because they had inches in compression and I was doing it the other way around. It's too hot in this room. The screen couldn't work. What's that?
Was that the same one that I showed you a couple weeks ago?
Could be. It was a compression with inches. We had to change the feet and all that stuff.
Was it the spring problem?
Yeah, it was a spring.
Yeah, it was the same one I
Yeah,
had.
we did. We did it, right? Oh no.
Well, I think we did it. It just wasn't pretty.
Oh, it was no. Well, it's not. All right. There's another spring.
Is that the same one?
Yeah.
No.
Yeah, it's exactly the same one. What a stupid problem this is. All right, let's set it up. I'm going to set it up at least. All right, it says 4.5 foot-pounds of work is required to compress a spring 2 inches from its natural length. All right, so right off the bat, they're giving you 4.5 foot-pounds of work and compressing the thing 2 inches, which we're going to have to convert to feet. We're going to do everything in foot-pounds, okay? So right off the bat, it's the same problem. Okay. Force is equal to kx. We've got to solve for k, as you know. Hooke's law, spring constant. 4.5 foot-pounds of work. Okay. 2 inches. Well, that's 2/12 of a foot. Okay. So we get 8 9/2 is equal to 1/6 k. Okay, k over 6. So multiply by 6. So k is equal to 6 times the 9/2. That goes in there 3. That's 27. At least this k comes out to be an integer anyways. Okay. That's k. Find the work required to compress the spring an additional 1/2 inch. Now, you got to be really careful here. The work is equal to, now, where are we going? We compressed it 2 inches from its natural length. So we're starting at a negative 1/6, 2/12, okay? 2 inches from its natural length. That's where we're starting. And we want to compress it an additional 1/2 inch. So now we're 2.5 inches compressed, okay? So it's 2.5, what have we done here? 12ths. It goes from 2-inch compression to 2.5 inches of compression, an additional 1/2 inch, okay? So this is a negative 5/2 over 12. This is a negative 5/24. Seems to me that's what we need to do, and then we need to integrate kx, okay? K is 27, x dx. Now, this is what Jim and I did beforehand, and WebAssign insisted the answer was 1.2, and we got an answer of 0.2. I disagree with WebAssign on this, so let's see what happens here on this one. I don't know what the answer they have is, but let's see what happens. You get 27, x squared over 2, negative 1/6, negative 5/24.
Should we just punch it in?
Yeah, 26, yeah, that's not a bad idea. You get this negative 520, that's 25,576 minus 1 over 36. It's a pain. And if you could do this, that would be good. They run it rounded to nearest 2 decimal places.
I got negative 0.0198.
0.0 negative. Okay, negative. Okay, I guess. Is that about right? I'm not sure you're going to get a negative out of this. Okay, you did this in the calculator, and you got what now?
I put in 27x squared over 2 for the integral, and I got negative 0.0198.
And you went from negative 1/6 to negative 5/24?
Yeah.
Okay, well, okay, so you get negative what?
0.0198.
0.0198. That doesn't look right to me. But that would be in pounds. And if that's what you got, you multiply by 27.
Yep.
Okay.
I get 0.21.
When you do this one out, you get negative 0.21.
I get 0.21.
Well, look, bless you. Anybody else have confirmation here?
0.21 also.
Yeah, okay. And if it's negative, if you're going up this way, positive if you're going down that way, but you get negative. Okay. Well, try that. What did he say?
1.2.
See, that's what it did with yours too. And I maintain that they're wrong.
No.
Yeah.
I don't know.
Oh, you don't know it said one, okay. You could try a positive 0.21. And maybe that we want positive work even though it's going in that direction. Should be negative compressing it.
Oh, you know what? I got 0.21 as well.
Oh, good.
Yeah. And I got a positive.
And it's positive.
Yeah, positive.
Well, that makes more sense to me. No, huh? I'll just change it for you. 0.21 is the answer.
Okay.
I don't know what they're doing.
As long as you give me credit.
Send me an email. Yeah, make sure I change it.
Thank you.
That's what it is. Okay, any others? Go ahead, Chris.
7, again, sorry.
Go ahead.
Number 2. Find the fluid force on the vertical side of the tank. Dimensions are given in feet. It's a triangle. That's also
It's a triangle. And can you give me the coordinates of the three vertices?
-4 on the x-axis, and -3 for the y.
-3 here?
Yep.
Okay. And you give me the density of the medium?
62.4.
Okay. Okay, let's find it. And again, I'm going to take half of it and double it. The force on this, what we're going to have is the equation of this line. Bless you. Okay? In order to convert this x distance into a y. So let's do that. Let's find the equation of this line first. This is 0, -3. Okay, 0, -3. 4, 0. The slope of this line would be 3/4. The intercept is -3. So you get y equals 3/4 x minus 3. Okay? That's the equation of that line. We're going to need that. The fluid force on that triangle is equal to twice the density function. Okay? As we go from -3 to 0 of the opposite of y times x. That's 124.8, -3 to 0, negative y, I'm going to take the negative out front, and I have to solve for x. So add 3, multiply by 4, divide by 3, and that's what I'm going to use here. Okay, you do? Okay.
Integrating with respect to x.
Ah, okay, that'll do it. And now what you have to do is multiply it out, integrate it, and it'll be okay. Any others? Go ahead, Carlos. What's that? You're stretching. Thinking me out, huh? Okay, Carlos. Yes.
Is there by any chance that you could, because I messed up on that same one that worked problem,
Yeah.
the last one. Is there any way that you could,
Yeah, just email me. You send me an email. Anybody else? You ready to go on? We have two things to do. Trig integrals and trig substitutions. It's all trig night, okay? That's what it is, all trig night. So let's take a look at these, all right? Wait, Carolina came in late. She didn't get the trig piece of paper, did you? Anybody else that didn't get it? Whoa, egg. What? Willis. These are trig things that you should know for calc. This is something you should know before taking calc 1, okay?
I didn't get one.
You didn't, huh? Okay. Did you get it, Marius?
Oh, yes, I did.
Okay. All right, let's start. Let's start with the trig integrals we know first, okay? Good place to start. With the trig integrals are what we're doing. The ones we do know, the integral of sine u, negative cosine u, cosine u, sine u, tangent u, secant U. Secant squared.